Hello, Common Core Geometry kids. So we're on to Unit 3. This is Lesson 1, and this is going to be an introduction to proofs. So the first thing that I want you to know is what you can assume from a diagram, okay? And what you can't assume. Okay, so this is one of the foundations of geometry, is understanding what assumptions you can make versus what assumptions you can't make. Okay, so for example, let's say you have this picture, and I have these two angles, 1 and 2. You are allowed to assume that those angles are congruent because they're vertical angles. No one needs to tell you anything, okay? So when you have a picture and you have vertical angles, you can assume vertical angles are congruent. So we're going to be doing 2-column proofs, statements and reasons. So the statement would be angle 1 is congruent to angle 2, and then the reason would be vertical angles are congruent. So this is a statement, this is a reason. Okay, the next thing that you can assume from a diagram is something called the reflexive property. So let's say I have this triangle and I have this side AD. You are allowed to assume that AD is congruent to itself. Now this is going to come up when we're doing triangle proofs and we're trying to prove that pairs of corresponding sides and pairs of corresponding angles are congruent. You will always be able to assume that AD is congruent to AD. Oh, by the way, in number 1, these marks that I'm putting, these arc marks, show that those angles are congruent. This X shows that AD is congruent to itself. So the statement would be AD is congruent to AD. And your reason would just be reflexive property. Okay, the next thing you can assume from a diagram is linear pairs are supplementary. So let's say I had this picture here, and I had this angle 1 and this angle 2. Okay, I would be allowed to assume that angle 1 and angle 2 are supplementary. So that would be a statement. Are supplementary. Okay, and the reason that those are supplementary is because linear pairs are supplementary. So the thing about these assumptions is that nobody told you anything. You literally were just given the picture, and from the picture you were allowed to make these assumptions. We'll be using these assumptions shortly. Okay, let me talk about things that you can't assume. From a diagram. This is equally as important, okay? So, when somebody makes a triangle that looks like a right triangle, you can't assume that this is a right triangle. Nobody told you that AB was perpendicular to BC. No one told you that angle B was a right angle. So you cannot assume angle B is right. something else you can't assume. So let's say I have a picture drawn. And it looks like AD bisects BC. It looks like that, right? But you can't assume it. So you cannot assume that AD bisects BC, even though it looks like it. Okay, what else can't you assume? Okay, so if I give you a picture and it appears, this is similar to number 1, right? It looks like this is a rectangle, but I can't assume it, so you can't assume a rectangle. You would have to be given more information. You can't assume a rectangle. Okay, I can't give you every single example that you can't assume, but you wouldn't be able to assume a rhombus, a square, all right? You wouldn't be able to assume an isosceles triangle. So if I gave you a triangle that looked isosceles, all right, this definitely looks isosceles, but I can't assume it unless somebody tells me that AB is congruent to BC, or if they tell me that angle A is congruent to angle C. So you cannot assume sides are congruent. Okay, you have to be given more information. You wouldn't be able to assume that angles are congruent unless they're vertical angles. Okay, so if I gave you this picture, okay, it looks to me like angle 1 and angle 2 are congruent. Looks like it. It looks like angle 3 is congruent to angle 4. Well, you can't assume it. Okay, so you cannot assume angles are congruent. Even if they look like they're congruent, that doesn't mean that they are congruent. Okay, likewise, if I just have a segment, say segment DE, and here's F, it certainly looks like F is a midpoint, but did anybody tell you it was a midpoint? No, right? So you cannot assume F is a midpoint. Okay, there's this great game that you can play on your computer. Okay, it's called, you can actually download it on your phone. It's called 50-50. It really shows you how you cannot assume things. In this game that you can download, it's an app, you're going to take geometric shapes and you're going to cut them in half because you want to have them split 50-50. You're going to really be grounded. You're going to realize that your assumptions are wrong quite often once the shapes get complicated. But I highly recommend this game. Okay? So this is an app. Okay, and it's free. All right? It's really great. Okay, something else you cannot assume. Let's say I have this triangle, and I have this segment here, and I want to prove that angle 1 is congruent to angle 2. I cannot assume that AD is an angle bisector. I don't know if it is or not. Okay? So cannot assume an angle bisector. Another big one that you cannot assume is parallel lines. So if I draw this picture here, I would love to say that angle 1 and angle 2 are congruent, because I would love to say that line AB and line GH are parallel. But I don't know if they're parallel. Okay, the only thing I could assume from this diagram is that angle 3 is congruent to angle 4. I don't know that angle 1 is congruent to angle 2. Okay, so you cannot assume parallel lines. Sorry about that, my phone was ringing. All right, so basically, guys, I think you're getting the idea. You can't just assume things. You can't assume anything, okay, other than what I said originally, which was vertical angles, reflexive, and linear pairs are supplementary. Okay, so now we're going to move on to some proofs, okay? We're going to be proving things, and we'll slowly add on to this, all right? So I showed you on the first page some examples of using reflexive property and using vertical angles are congruent, okay? So we call these mini proofs. And what's going to happen is eventually we will have proofs that are 14, 15, 16 lines long. And in order to succeed at those proofs, you're going to have to succeed at mini proofs first, because they'll be embedded within the larger proofs. Okay, so let's say, okay, here's an example, example 1. Let's say I have this segment, and then I'm just going to put 2 points on the segment. I'll call this A, B, C, D. Now, what's going to happen is you're going to be given information, okay? So let's say I gave you, given, AB is congruent to DC. Prove AC is congruent to DB. Okay, so you have to come up with a plan. You need to look at the picture. You need to think about this. So I know this. I know that these two little red segments are congruent. But my goal is to prove this yellow segment is congruent to this yellow segment. Well, what are both of those yellow segments missing? They're both missing BC, correct? So the way you would do your proof is you would start off, you make 2 columns, statements, reasons. Underneath the statement column, you'd put your given, AB, congruent to DC, reason, it's given. They told you so. So, number 2, I'm allowed to assume that BC is congruent to itself. And that was on from the beginning of this lesson. BC is congruent to BC. Why is BC congruent to BC? Because of the reflexive property. Okay, so now what we're going to do is we're going to add AB and BC and DC and CB. So we have AB plus BC is congruent to DC plus BC. Put a little semicolon and replace those sums with their answers. So what is AB plus BC? That would be AC, right? What is DC plus BC? That's right. That's DB. Okay, so that is the addition property. So with the addition property, you're going to have a small piece and a small piece, and you're going to want to prove that a large piece is congruent to a large piece. So you're going to have to add 2 smaller pieces together to get a larger piece. Now we're going to do a very similar proof, except it's going to be the subtraction property. Okay, let's take a look at the difference. Example 2. I'll do this one with angles though. Okay, so I have these angles. I'll call them angles 1, 2, and 3. So I'm going to give to you, all right, I need to put letters in the picture too. A, B, call this C, D, E. Okay, given. Angle A, B, D is congruent to angle C, B, E. Take a look at the picture. You'll see that these are two large angles. So I will highlight the one on the left in red, and I'll highlight the one on the right in blue. Notice that these angles are overlapping, aren't they? So what I want you to prove is that angle 1 is congruent to angle 3. Well, I have this red angle and this blue angle, but what I want to prove is this little yellow angle here is congruent to this little yellow angle here. So what ends up happening is you end up wanting to get rid of this part from both that red angle, okay, and that blue angle. You want to get rid of angle 2. You want to subtract it. Well, in order to subtract it, first you set up your proof, statements, reasons, and you need to start by putting your given, angle A, B, D, congruent to angle C, B, E, given. And then we're going to put that angle 2 is congruent to angle 2. Reflexive property. So before you can add or subtract angle 2, you need from angle ABD and angle CBE, you need to first put it in the proof. Okay, so now we're going to subtract. So we're going to say angle ABD minus angle 2 is congruent to angle CBE minus angle 2, semicolon, replace these differences with their answers. Well, the answers are angle 1 is congruent to angle 3. And that would be the subtraction property. Okay, so pause it for a moment and copy down this picture. I'm going to teach you something called the substitution property. But at the same time, I'm going to incorporate parallel lines and an angle bisector. Okay? So, let me put letters in this picture. All right, given AB is parallel to CD. So this is given to you. We're not assuming it. And you're also given that CD bisects angle BCE. Okay, we're going to prove that angle 1 is congruent to angle 3. All right, so here's how we do this. We start with our first given. We see what conclusions we can draw from that, okay? So statements, reasons. Number 1, AB is parallel to CD. So what you need to think to yourself is, how does this knowledge help me to get information about anything that will lead me to be able to prove angle 1 is congruent to angle 3? Well, I want to prove things about angles here. So when these two sides are parallel, put these little arrows to show that they're parallel. You will see the Z in the picture. See the Z? This pair of angles, 1 and 2, they're called alternate interior angles. Well, in this problem, they're congruent because of the parallel lines. So what you would say is angle 1 is congruent to angle 2. Your reason for them being congruent is because we have parallel lines. So when lines are parallel, then the alternate interior angles are congruent. AIA means alternate interior. You don't have to write it out. You are allowed to write AIA. But look for the Z. Forward, backwards, however. Look for those angles in the Z. Okay, next. We have this angle bisector. So we learned in the last unit what an angle bisector does, right? We also learned that these angles are congruent because of parallel lines. So the last unit, as I told you, prepped us for this unit. So I'm going to put that given. CD bisects angle BCE. You are also allowed to put both givens in the beginning in line 1 if you feel like it, okay? Now, after you use a given, you should check it off. You have to use all the givens. You have no choice, okay? They're not going to give you something you're not going to need. So you can either put them both in line 1, or you could just put the first given and then draw your conclusions from that given, then put the second given and draw your conclusions from that. It's up to you. I don't have a preference. Okay, you can make a different choice than I make. Angle 2 is congruent to angle 3. That would be the conclusion from this given. And the reason would be that an angle bisector splits an angle into 2 congruent angles. Okay, so now I want you to think about this. I have angle 1 is congruent to angle 2, but angle 2 is congruent to angle 3. So think about it. If angle 1 measured 50 degrees, let's just say, angle 2 would measure 50 degrees, angle 3 would measure 50 degrees. So wouldn't it stand to reason that angle 1 must be congruent to angle 3, since they're both congruent to angle 2? So some people will call this the transitive property because of the way it's written, 1, 2, 2, 3. We just have to use substitution in geometry. So what we're going to say is that angle 1 is congruent to angle 3, and that's substitution. What substitution means is that you're replacing an equal with an equal. So let me show you what I'm talking about. Okay, so I have, this is just scrap worked in here. I have that angle 1 is congruent to angle 2. Then I have that angle 2 is congruent to angle 3. So what ends up happening is it's as if these cancel out. Think of it that way. They're both 1 and 3 are congruent to 2. Therefore, they're congruent to one another. That may help you to see this. Okay, this is going to be the end of the video. I need to show you a comparison side by side to side of these 3 problems. I just realized I wrote example 5 here. Okay, these 3 questions are very similar. It's all in the wording, okay? Geometry is actually very good practice for debate because it's all in the wording. It's how you word it. In the first question, we're given a midpoint. We want to prove that AG is congruent to BG. So you have your statement, you have your reason. My statement would be G is a midpoint of AB. You can abbreviate midpoint. So this is given. I can jump right to the conclusion that AG is congruent to BG. They're congruent because a midpoint splits a segment into two congruent segments, right? A midpoint splits a segment into two congruent segments. So what happened here, kids, is I was given a midpoint. So when I gave AG congruent to BG, look at my reason. My reason was a midpoint splits a segment. Pay attention to the word that's given, because the word that's given is going to become your reason. So if we look at example 5, my statement is DM bisects AB, right? So that's given. So then, when I prove that AG is congruent to BG, what would I have to say? I'd have to say a segment bisector splits a segment into two congruent segments. You need this word segment in front of bisector. Make sure you make that stand out in your notes. A segment bisector splits a segment into two congruent segments. So we were given a segment bisector. Now they didn't write the word segment, but you have a segment bisecting a segment. Well, it's a segment bisecting. That's why it's a segment bisector. That goes together. Let's take a look at the last one. So my statement is that CG is a median. Given. I want to prove AG is congruent to BG. So my reason would be a median splits a segment into two congruent segments. So look at what was given. We were given a median. What was used in the explanation? A median. You get the idea, guys? All right, that concludes this video, and we'll continue next time. Thank you.